Okay, this is lesson 9.4, choosing a data display. So this is the key idea. You can find this in your book on page 394, and it's going to be very useful for you to have when trying to select the most appropriate one. So we're going to kind of discuss each one individually before we continue. So when you're looking at the pictograph, it's going to show data using pictures. The most important thing here is that the pictures are the same for each piece of data. In the bar graph, it's going to show data in specific categories. The bars need to be the same width so that it is not misleading. Things that are categorical are like favorite color or type of sport or something like that. In a circle graph, it could again show categories, but it shows it as percentages comparing the parts to the whole. So when you have something that can be compared in percentages, that part of the circle graph would then be a percentage of 360 degrees, so that when you see it, you can tell, like in the one shown, green is by far the biggest, the purple is by far the smallest, and things are sized appropriately. In a line graph, it shows how data changes over time. So if we're comparing maybe the stock market, or when you get to high school and you need to prepare a graph for an experiment that you just completed where you measured the temperature of a reaction every so few minutes or whatever, however the time frame was. That would be the most appropriate graph to draw then, is change over time, how the temperature changed versus the time. So you're comparing two things in that. For a histogram, we're going to show frequencies of data values in intervals of the same size. So note that we use bars, but it's not the same as a bar graph. The bars in a histogram are touching because the label along the bottom, the x-axis, are in intervals. So it could be like the number, 1 through 9, and then 10 through 14, and then 15 to 19, whatever. The intervals have to be the same, so that's important. But they're continual is what I'm trying to say. So it could be age groups. It could be, 10 to 19, and then 20 to 29, and 30 to 39, and things like that, so that as one number ends, the next number begins. Along the y-axis is frequency, so you're measuring an amount. So when you group everybody in that one bar, some of the information gets lost. So a stem and leaf plot, if you're not working with a lot of data points, could be another way to show the intervals, because you can see the first row there of the stem and leaf plot is the 10 to 19 interval, but it shows each individual data point. So we can get more specific information, and we can do the mean, mode, median, range from a stem and leaf plot while it's still in intervals. A box and whisker plot will show the variability of data by using quartiles. So there's 5 important things that we, place on the number line, and then the left side, you can see a whisker. That is 1/4 or 25% of the data. The box is divided into 2 sections, and you can see that the left side is smaller. That shows more consistency. There's the same number of data pieces in that side as there are spread out in the right-hand side. So the bigger side of the box has 25% as well, and then the right whisker has 25%. So it kind of gives you a spread of the data, and then it allows you to make decisions based on more consistent data points. For a dot plot, it shows the number of times each value occurs in a data set. So again, it's for smaller, close together range grouped data where you want to be able to see the individual points. A scatter plot is showing the relationship between 2 data sets by using ordered pairs in a coordinate plane. Again, we learned about those this chapter, and drawing a line of best fit. So when you're comparing 2 different things, you might want to consider a scatter plot. So in our first example, you need to choose the appropriate display. Now it's important to note that sometimes data can be represented by more than one display. That's key, right? We've learned a lot in this chapter about understanding that there are sometimes more than one right answer, because we're not used to that in math class, are we? But when you're talking about data, and when you're talking about interpreting data, there's reasonable conclusions that can be made therefore allowing for a little bit of a margin of error, and then you get more specific into the statistics when you start calculating those things. But if you're looking at A, the number of students in a marching band each year, a line graph could show how that's changing over time, so that would be appropriate. You could even put, if you wanted to, the years at the bottom, right? And then you could make it a bar graph. Even though it's categorical, this isn't something where you need to calculate, possibly the rate of change, because that would be a line graph. You could definitely use the slope information. But, depends on what you need from it. But something categorical that can show the years individually, or the line graph would be great. For B, a comparison of people's shoe size and their heights. Well, this would be a great one for a scatter plot, because you're comparing two different data sets. And they might be all over the place, because there's really, we know, no correlation or no relationship between their age and their shoe size. I'm sorry, this isn't age and shoe size, this is shoe size and heights. You could have a tall person with a small foot, or a less tall person with a large foot. So there's not, proportions are different for every human being based on their genes, not based on this kind of information. So on your own, choose an appropriate data display for the situation. So again, we're going to be giving some sample answers. There may be more than one. What's going to be key is that your reasoning backs it up, that you understand the meaning of that graph. So you want to use that key idea section in order to give, reasons why. So the population of the United States is divided into age groups. When I see age groups, I automatically think of intervals like that 10 to 19 or 20 to 29. So the first two graphs that come to mind that are based on intervals are histograms and stem and leaf plots. The histogram would be best because when we're talking population in the United States, we're going to have a lot of data points or a lot of people. So to look at each individual one would be too hard to put into a stem and leaf plot. So for number one, the best one would probably be the histogram. Okay, the histogram, because it shows frequencies of ages in intervals. Okay. And this is, again, just a sample answer. There could be another one, and in a later example, we're going to take a look at multiple representations, and you'll see how some of them are a good fit and some of them are not. For number two, the percents of students in your school who play basketball, football, soccer, or lacrosse. Two different things come to mind. Immediately when I see percent, I think circle graph. So a circle graph would work. However, a bar graph also shows the specific categories of basketball, football, soccer, and lacrosse, and might be a little easier to make because you won't have to use proportions to calculate your degrees. So the bar graph would probably be the best for what we need it for in this situation, because it's the ease of use and how easy it is to make, because it shows specific categories. All right, here's an example of looking at multiple representations. So the data is on the left in the notebook. You record the number of hits for your school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits has changed during that 5-month period. So looking at A, we have the website hits, we have the number of hits, and the month. Each bar represents a different month, and the bars are the equal size to each other. Therefore, you can see that the hits are increasing. So it is appropriate. For B, now we have a histogram. It takes the intervals of the number of hits, so it completely leaves out the information about the months. And it kind of just blurs everything together. So what could you gather from this? The only thing I see is that we had no hits between 1,200 and 1,599. That really isn't very useful. So because it doesn't show the number of hits per month or how it changes over time, it's not appropriate because we can't gather the information from it that we want. Looking at C, when you look at the line graph, because obviously a line graph changes over time, it works great to show us the increase. So let's see if some other ones would work. Do you think that a dot plot would work to show the data over time? The answer No, it would not. So we're using the same information from example 2 on website hits. And no, a dot plot would not show the number of hits over time. Uh-oh, sorry about that. Preview of what's coming next. Okay, what about a circle graph? Do you think we could use a circle graph to show the changes over time? And yeah, we actually could. A circle graph would work. Because what a circle graph is going to do, it's going to show a fraction or percent of the total number of hits for each month. So we could still make each part of the circle then be a month, so you still have both pieces of data. So yes, a circle graph will show the percent of the total number of hits for each month. And finally, the stem and leaf plot. Not going to be a good one, right? This is one would, again, won't show how it changes. Will not show how it changes over time. So we just looked at one example of data and we saw 3 different types of graph that would work. Okay, so now to describe or find and look for misleading data. Which line graph is misleading? So you look at the left and you look at the right. All of the labels are the same: box office revenue, total revenue in billions of dollars, and the year. And on the left, it's like, wow, that's a huge increase from 2005 to 2009. But on the right, it's not. So I'm wondering what's wrong here. And when I look at the left a little more closely, I can see that there's a break in the axis. And it's shown by this little squiggly line, and you can kind of see it right here. And that goes from 0 to 8. Then it starts counting by 1. So it goes from 8 to 9 to 10 to 11. So what they've done is, it makes it appear that the total revenue increased rapidly, but the graph on the right has an unbroken axis. It is a more honest graph, and it shows that the total revenue increased slowly. So learning to be able to identify misleading data, because if I'm trying to sell you something and I think that it might sell more if I show you the graph on the left, I might do that. So as a consumer, this is why you're learning about this, is so that you can beware and not be misled into thinking that something is better than it is or worse than it is or whatever the case may be. So just always look for things that says, you know what, those intervals are a little bit off, so I'm not sure, I think that's a little skewed, and there might be a little bias in there. So definitely be on the lookout. And so we're going to try to identify and analyze some misleading data. So here's a case where a volunteer concluded that the number of cans of food and boxes of food donated were the same. Is this conclusion right? So I look at the pictograph and I'm like, wow, they go out about, if I'm looking at just like the bar height, right, to the right, the cans and the boxes are almost lined up, so that kind of looks like they're the same. However, it's a pictograph and they should be represented by the same icon so that we can see exactly. If you count the number of cans and then count the number of boxes, you will see that the boxes are about half. So the conclusion is it's not accurate because they changed the picture. One icon is larger than the other. So let's take a look at a couple graphs. So for number 6, it says explain why the data in display is misleading. And on the left, for the concert tickets, you have your ticket price and your rock band. Because the tickets vary in width and the break in the vertical axis between 0 and 35, right? the difference in ticket prices appear to be greater. So it looks like C is, wow, ticket price so much greater than A, but look at the difference in the numbers, right? It's maybe even $13 at most, and that's not that great of a difference because it goes from 0 to 35 and then counts by fives. So that would be why, and the ticket width is also different. Looking at number 7, the bars become wider as the years progress, making the increase in profit appear larger. So in 6, I'll rewrite this for you so that you have it. Let me get a pen. The tickets vary in width and the break in y-axis make it misleading. Makes it appear that band C is a much greater ticket price. And for 7, the bars become wider as the years progress. Making the increase appear greater than it actually is.